Thank you for attending this early session. I hope all of you have had an amazing event so far. And I hope you guys enjoyed last evening's gala dinner, traditional vibes and so on. My name is Ali Al Ibrahim. I work as an peering and interconnection expert in Zoe. I've been in the industry for almost 15 years. 15 years weren't completely focused on peering, so I started in network planning and design, doing some fixed access last mile designs for corporate customers, enterprises. And then in 2017, I joined the Mantle wholesale team as a team leader, product management. So I looked after some of the wholesale products with our sales team, coordinated closely with them on the type of products they're doing. And exactly 5 years from now, I started my basically journey with peering. And yeah, it's been an amazing journey so far. Peering, so our session today is about peering content localization. I'll start off with an intro into peering, what peering is, type of peering arrangements that can be basically established, why it's done, and the importance of content localization for us in the region. Why most operators are now pushing to have some kind of local presence from OTTs, hyperscalers, CDNs. It's intended to be more of a educational session about peering rather than a technical masterclass, as they call it here in carrier community. So I hope you guys get to enjoy this. And I don't want to bore you guys a lot, so yeah, I'll kick it off. So yeah, origins of peering. So before peering came about, there was basically the transit era where tier one networks, or the biggest, the traditional historical companies in the US that first started serving internet. So in the early days, late 80s, early 90s, you would have had to pay for basically internet access through a tier one provider to have reach into the internet. Then soon after that, peering started to show up bit by bit, mainly in the States, where these large backbone providers basically started to interconnect in facilities called NAPs, network access points. So basically they would come in, co-locate their equipment in these locations and start exchanging domestic traffic between their networks. So traffic of their own customers within these facilities. And towards early 2000s, late 90s, I would say, soon after the NAPs started forming up in the United States, internet exchanges started to emerge worldwide, mainly in Europe. So the historical, well-known internet exchanges were basically in Europe, and that's where peering really started to pick up. A lot of people started to adopt peering and, see the benefits in peering over internet exchange points rather than buying IP transit services from the incumbent internet service providers of those times. So what is peering? Well, peering is basically, in the most simple terms, is basically an interconnection between two networks, direct interconnection between two networks, voluntary interconnection. Peering coordinators would reach out to, the ISP or the provider, the company they see there's, good traffic exchange between their networks, and they would see if they are present somewhere in a common location for them to start interconnecting physically and exchanging traffic between each other. And if it wasn't for peering, I think the internet of our days wouldn't be as enjoyable as the seamless connectivity we get with most of the apps we interact with in our days, be it video, is basically because of peering. So the main building blocks of the internet of today is basically peering. Without peering, internet wouldn't have flourished as we know it in our days. Key benefits. So there is two different types of basically peering. There is the public peering and private peering. I'll get to that in a bit. On the top, as you can see, settlement free. Compared to IP transit providers, where you had to basically pay them for the service, peering didn't incur much costs on you. You basically had to be present in an internet exchange or in a facility where parties you want to connect with basically are available, and you're only a cross connect away from them. And it's not completely free, but the cross connect is is basically chargeable, but it's a really marginal cost compared to the fees you had to pay basically for IP transit. Key benefits: low cost, lower latency, high reliability. So before starting to explain what public peering over internet exchanges is and IP private network interconnects, I just wanted to get the audience familiar with the type of costs that internet service providers had to basically deal with. Early days of the internet emergence, so when the internet first started peering, there wasn't really much internet exchanges around. Not a lot of networks were deployed within these exchanges. So dominant connectivity for internet access was basically through IP transit providers. And they would charge you based on your per MB usage during the month, where you would agree on some 95 percentile average usage over the month times by the per MB cost. And based on your utilization or usage of that port, basically you might end up paying something as high as, in the millions. Scale-wise, it wasn't really flexible for providers because, well, in the early 90s, internet wasn't really heavy on heavy on traffic. So it wasn't really high loads and high volumes of traffic being exchanged over these links. So it was maintainable for some time, but as soon as we hit the early 2000s, new technologies started to emerge. There was a boom in traffic intake, 3G networks, fixed access networks. So you had DSL networks, GPON networks, and the user demand for internet just grew like nothing. And basically, that's where people started to see the benefit in joining internet exchanges. So as you could see, the comparison in prices, soon after the 2005 point where these new technologies started to emerge, we started seeing more people joining internet exchanges. People started to see the benefits of joining these internet exchanges, and economically how they could have lowered their operational costs, because the moment social media started to, handsets became accessible, fixed networks became widely accessible also in countries. There was high demand for internet access, mostly because of the new social media apps and interactive websites that came up. And basically, these networks, content providers plus ISPs started to join these internet exchanges to exchange traffic directly between each other, instead of having to scale the growth in traffic on paid links that would eventually break their backs, given the traffic volumes that we've reached in our days. Prices are quite rough, not that accurate, but yeah, from available sources, publicly shared sources that were available. Just to get a sense of what type of differences in economy between having an IP transit provider providing your internet for you, or opting to connect into an internet exchange that would basically save on you a lot of expenses, and you would get more optimized traffic exchange between networks and basically better operational costs. So starting off with internet exchange points. So internet exchange points are basically a group of networks connected over a shared switching fabric to exchange traffic over a route server. So the type of networks that you would usually see in internet exchanges are internet service providers, research and education networks, social media networks, cloud service providers, enterprises. So the bottom two, gaming and so, are basically the OTTs, or the content delivery networks. Those type of content would be hosted on top of these networks. And historically for regional operators, internet exchanges were not really a thing. So for us to manage to enter such ecosystems, we basically had to use our backbone net capacities to get into Europe, because Europe has always been our main access point to the global internet, where most of these parties were traditionally based after they started to move out and shift out of the US. As it wasn't easy. The point I'm trying to say, for regional service providers, connecting to an internet exchange to gain the benefits of basically the commercials or the economics of connectivity wasn't as simple as the European players, where they had it local in their countries. Connectivity into these data centers were easy. And for us, we basically had to activate international traffic into these metros to be part of these internet exchanges and get the benefits of getting traffic directly from the content providers that were popular to our end users. Benefits of joining internet exchanges: affordable entry point for ISPs, CDNs with low traffic profiles, rapid access and diverse local, regional, international networks. So as you can see, the type of networks, once you're into these exchanges, there's like a vast amount of networks coming from different backgrounds, different countries, international, regional, plus other content delivery networks. Benefits again, local traffic is being exchanged directly between networks. There is no intermediaries or no third-party network sitting in the middle to carry your traffic and pass it off to the destination it's supposed to be getting to. Cons, shared infrastructure. So because people connect over a switch fabric, usually you don't really know the traffic levels on your counterparts' subscription capacities, basically. So there'll be serving everyone on that internet exchange or everyone connected to that internet exchange point. And if the port or the capacity they're connected to reaches a saturation level, they would start limiting the traffic that is being distributed between everyone that is demanding that traffic basically from a certain network or so on. And yeah, again, unpredictable traffic volumes, because some days you could have good traffic, let's say from Google. Tomorrow, because they're serving traffic to someone else, your traffic levels might dip until their port starts to ease down on terms of pressure that's on it. Use cases, it's good for ISPs that are emerging, have low traffic profiles, seeking efficient reach, and wanting to start to offload the traffic that was dominant on their IP transit links, and to shift them onto more economical corridors and links, basically to have that balance between paid links and more accessible economical connectivity. An example of very well-known internet exchanges, DKIX in Frankfurt, AM6 in Amsterdam, and Links in London. These are like the pioneer of internet exchanges when it first started. These guys were the ones to be connected to get the most benefit out of the people that are deployed or interconnected to these places. So places like DKIX with one port connecting to the route server, you can access 1,000+ of networks, diverse types of networks, content networks, ISPs, educational networks, you name it. Moving on to private peering or PNIs, private network interconnection. So this is a basic diagram, show you what happens. So it's basically an AS to AS direct interconnectivity. So for anyone who doesn't know what an AS is, it's an autonomous system. Each and every network that is registered or available on the net needs to have an AS number. It's like an identification code for people working in tech or engineers to identify where this traffic is coming from. Where am I receiving the type of traffic? So it's an AS to AS interconnection over a protocol called BGP. And interconnection could happen on different flavors of capacities, depending on the type of traffic you have with those networks. You can arrange to interconnect, and then monitoring the growth of traffic, you can easily scale these interconnections, given the trends of traffic that you see on these ports. And the quality you get out of this is that, as I mentioned earlier, there's no more third-party networks that are handing over your traffic over the global internet infrastructure, not knowing how efficiently they're basically sending traffic from source to destination. So it could affect your end-user quality of experience and access into certain networks. So yeah, it's a direct, dedicated interconnection between two networks. And it became very useful because people started to use it as a interconnection to shift heavy volumes of traffic that people started to see grow over internet exchanges and couldn't really have much of a control on it. So they opted for private network interconnects. And private network interconnects wouldn't just happen. You wouldn't just walk up to someone and ask him, hey, can I directly connect to you, basically. Each and every network would have some kind of a peering policy where they would set certain thresholds of traffic for people to start interchanging traffic between each other. use cases, ISPs with large customer base. In the industry, we call them eyeballs, so basically the people who are viewing the content or demanding the content to their handsets or to their devices, who want to peer with hyperscalers and CDNs that account for some of the most consumed content and services on the internet. So the names you see down there are usually always, like at least the top 5, there will be always one of the top 5 networks that are heavily sending you traffic. They host almost most of the consumed, basically, traffic that we access over the internet. So it will most probably start with these parties, and then with time, as traffic grows, other parties might start to appear, and then you might start opting to interconnect with those parties. Pros of private network interconnection: dedicated capacity, reliable performance, latency is always optimized, you have greater control over routing in comparison to IP transit networks or internet exchanges. And then scalability is usually predictable. Over time, you might notice certain trends of traffic and how it's growing, and you can set yourself certain thresholds to upgrade before your ports become completely congested with those parties. So these were just basic examples of the early internet days and the type of content that people used to access. And as you can see, probably maybe some of you are familiar with some of the examples or the type of things that people used to access the internet to basically interact with. And if there is something which is basically in common between all of them, is that most of them are heavy on text, very low bandwidth, not heavy on traffic volume. So it's not like video, images. Well, towards the end of it, some of that starting to appear, but a lot of them were really low res, not very sharp in terms of quality. And, traffic levels that were needed was very low. But comparing it with today's type of traffic that we see in our days, online gaming, static video on demand streaming, video conferencing, interactive live, like broadcasts of sports events, entertainment events, and so on. Why I wanted to present this is I added a column here showing latencies and what would be the best latencies for someone to have a good quality of experience, accessing whatever type of content it was, and accessing it in an ideal way. So latency is a big factor in regards to how your experience would be accessing these types. And why I wanted to touch on this point is basically for us in the region, peering into Europe wasn't enough, because latency is defined by your location and comparable to where the content is originated out of. And in the region, because of our geographical location, getting into European metros, that alone is around 90 to 120 milliseconds. So having private network interconnections wasn't enough for us to optimize or localize traffic exchange within our countries compared to European or American internet service providers, which led to the emergence of CDN caches. So CDN caches supplemented internet exchange points, peering connectivity They were, content delivery networks and hyperscalers came up with an idea of deploying edge caching devices within internet service providers' networks. And these basically would act as a store for popular content that was being accessed by people within our metro. So a good example of CDN caching is basically YouTube videos or Netflix content. So before having these CDN caches within our networks, if Yasser decided to watch a viral video that popped up on YouTube or something, he would have had, the moment he would have clicked on that link, the request would have traveled upstream to some other network other than our regional networks to basically fetch that content. But once CDN caches emerged, the first request would go upstream where that video was hosted or where it originated. And then the following users who want to view that content would basically have it cached directly on the CDN cache locally in country. So it's a difference between accessing content at 120 or 150 milliseconds comparable to accessing it locally over 5 or 10 milliseconds, dependent on where you are geolocated in that country. Roles, so I linked CDN caches to content localization because it plays a big role in regards to how we are striving to localize content within the region to serve our end users with better quality and quality of experience and access, basically. Role in localization, deliver content from within ISP instead of long-haul routes, improve video gaming software updates, so update iOS updates, new releases of games where you have to download huge volumes of traffic in gigs, basically, to download these new updates and stuff. This eventually started to happen over CDN caches. Benefits for ISPs, save international bandwidth. It offloads traffic that were consuming our backbones into Europe and other locations and makes us utilize them or monetize them in other ways to connect people from the region or across the region into Europe for connectivity, basically. Reduce upstream backbone load and benefits of end users, faster access and lower latency, stable quality of experience. Evolution of ISP strategy. So these are the, I would say, 4 phases that most internet service providers would traditionally go through. They would start off connecting to an IP transit provider who wouldn't be really as reliable as exchanging traffic directly between you and the end source network. Then we shifted to the cost efficiency phase where people wanted to start to lower their dependency on IP transit networks. They started to offload traffic onto public peering internet exchanges. Then private peering comes into the picture once you have larger volumes of exchange of traffic between end parties. Eventually, hybrid phase. This was called by me, so it's not like a standard phase in the industry or anything, but I wanted to call it a hybrid phase where you would have a smart mix of all of the type of connectivity or reachability into the internet, managing them based on how you see fit for your network and customers. And I'll just give you a quick timeline of Omantel, how they started off their journey into internet access. So we started off in 1996, as per Salim, our director there, director of networks. Over, I I think a few E1s or an STM1, Salim. I think it was an STM1 into Europe. And then in 2008, 2009, we joined our first internet exchange, AMP6, in Amsterdam. So that happened around 2008, 2009. From there, we started shyly interconnecting directly with some networks. And eventually, we ended up having, in 2010, I think we embedded our first CDN cache within our network. It was Google. It happened around 2010, 2011, I would say. And yeah, this is the typical growth of an internet service provider. Future of peering. So traffic patterns are only going to grow. Hyperscalers, CDNs will continue dominating traffic flow over internet corridors. And now, probably some of you have heard in previous sessions, with AI coming into the picture, traffic is only going to grow, and we will need to have more content localization for people to adopt these changes in the technology scene more closely. So we will need to have more network operators partnering up closer with hyperscalers to enable these deep edge deployments within ISP networks. Providers will also have to jointly invest with hyperscalers or OTTs to have more resilient global traffic corridors to avoid outages. And hyperscalers and CDNs collaborate closer with local ISPs to localize and optimize content delivery by establishing more CDN caches and edges within local ISP networks. Long term, peering will remain as an enabler of the digital transformation. Peering is evolving from a cost-saving and traffic optimization practice into a strategic enabler of the digital future. And I think the future is, the future for peering is collaboration over competition. Aligning operators, hyperscalers, CDNs, and to power the region's digital transformation and have a real digital boom in the region. I think I'm almost over, but just one quick point I wanted to focus on was enabling digital ecosystems and how we've reached to a time in the region where we really have to start realizing this long dream, basically. Having better connectivity between our borders, easier, accessible connectivity between us to make this ecosystem basically thrive. We already have a good base of deployments within our region, but reaching them is becoming very expensive. Everyone is charging a hand and a leg for access into these networks. And for the ecosystem to basically thrive, we need to have all of these attributes come together to make this region a real global digital hub and a real connectivity hub for everyone to interconnect and basically transit between East and West. I'd like to wrap up over here. I'm going to skip some slides. But yeah, I wanted to speak about the coming together between us and Zain and how this signs the shift toward our next strategy, which will be basically enabling the region and other hyperscalers to have a more seamless, basically, connectivity and reach within the region. We dominated our domestic markets, And we came together basically to shift to our next vision, which is empowering the region and having the region act as a real gateway and transit point between Asia, Europe, Africa, and the region as a whole. We're working on multiple projects to interconnect the geography between our OPCOs, seamless corridors that would connect you across borders, and hopefully it will incentivize better pricing for connectivity and access to neighboring countries, and act as an incentive for OTTs, global hyperscalers, to come into this region and see it more attractive for, we can basically complement each other. If Oman has the dense fiber subsea connectivity, UAE has mature internet exchanges, Saudi is booming like nothing. So I think coming together and collaborating together can really shift the dynamics of the region and realize it as a global digital hub. And something that we feel very proud of, and because of the efforts of our team and our customers, Zoe's network is ranked as the leading AS in the region. I didn't want to offend anyone over here. This is publicly accessible data, basically. It's analyzed, and basically they come up with these based on some certain parameters. So what is AS ranking? AS ranking basically reflects how well connected the network is, the amount of, I would say, networks that you would be able to reach by connecting to that network. So the better the ranking is, the more connected, the more reachability you will have connecting to such networks. And yeah, as I said, because of the efforts of our team and the trust from our customers, we managed to reach this amazing milestone. And it's only going to drive us to deliver more, hopefully, within the region. Thank you. Shukran.